Welcome to the special edition of the Uptime Wind Energy Podcast. I'm your host, Alan Hall, along with my co-host, Joel Saxon. Our guest is Jonathan Zalar, managing partner of IWTG Consulting, and IWTG is based in South Carolina in the United States. Jonathan has a long career in the wind industry, working for 22 years with GE, 13 years with GE Vernova. Specifically, Jonathan has a wealth of knowledge from both his work in the field and in the engineering offices. He's a mechanical engineering major and also holds an MBA. So I put you in a very select class, Jonathan, which we're going to tap on here. Jonathan, welcome to the program.
Thanks for having me. I appreciate you guys taking the time.
There's not a lot of engineers that go after their MBA and then stick to engineering. They tend to go to MBA and they go into the business world and have a nice comfy office. And you took the other route.
Yeah, I went right into my MBA after my undergrad. Guess I want to stay in college a little longer.
Yeah, that doesn't make you a bad person, okay? I wish I was still there.
So, Jonathan, you have really a wealth of knowledge here on what happens in the field because you're out there doing it and interacting with the engineering groups that were doing the design work and support work at their offices. And one of the issues that Joel and I get wrapped into a lot is RCAs. And people ask us about this all the time. And we were just at an insurance symposium a week or two ago, Joel and I were. And everybody has a different perspective of what actually happens and what an OEM does behind the scenes, because there's a lot of things that happen behind the curtain that unless you really are on the inside, you just don't know. But there's a lot of good positive things that an OEM is doing during an RCA. So I just kind of like to walk through what happens during an RCA. If you had a blade issue out in the field and you call the OEM, what typical things happen there? And maybe you can just kind of walk us through what that process is.
When something like that happens, it's like a major event. And, GE and other OEMs have protocols in place, first of all, to ensure safety, right? Like, is everybody okay? And then, then it's like, all right, now it's time to put your CSI hat on and go investigate.
Horatio Zalar, is that what it is?
While this is all happening, while you're working with the customer, it'd be like, hey, can we come here? We're going to send, these experts out there to go look at whatever it is, a blade, for example. The teams are also looking at the data because when a event happens, there's data collected on the turbine. So there's engineers looking at that data, trying to understand what happened from a data perspective while you're mobilizing people to go there. And being able to access the turbine can take weeks, sometimes months, depending on time of year and how the blade is oriented. So it does feel like it takes a long time, just to get started sometimes.
I know, so just the pictures that you see online, right? When there's a failure, and this is blades, lightning strikes, nacelle fires, whatever it may be. But a lot of times you see, we just looked at one the other day, Alan, where it was it looked like spaghetti, right? The blades were ripped up and the tower was bent over and stuff. And to look at that and say oh, we'd like to go do an investigation on that. Like you said, securing the site and being safe first is one thing, because you can't expect to bring anybody in there until that is, because it's like if a wind gust came one way, the whole thing could come down or something of that sort.
There's procedures in place to go analyze the way the turbine's currently situated, what the wind is, to go make sure something like that doesn't happen. Yeah, safety is the number one thing for sure.
Yeah, but and then I guess on the outside of that is being, say this is it doesn't matter, OEM X turbine. The people from OEM X will have access to data behind the scenes usually, right? If it's pretty new turbine, most of the time they're connected somehow to the SCADA system or the controller, so they can start their investigation even before something happens in the field, is kind of what you're saying.
They're trying to do two things. One, look at the data to understand if they have a good idea, if it's already an issue that they're working on. And if not, then they're collecting as much data as they can and just, when the investigation actually starts.
So is part of the issue that I've seen on some of these investigations is the investigation starts too late, right? By the time they get everybody spooled up, particularly on blades, a lot of times if a blade's been hanging, they're damaged and the turbine's shut down, you lose a lot of that fine detail that you have. I think it does seem to be important that an operator contacts the OEM quickly to get something started, get the process started.
Right, especially with a blade that banana peeled, for instance. If it's hanging out there for a week, it's just rubbing, and it's rubbing away evidence, basically. With drones that have come into play now, that helps for sure, because you can send a drone out there and a turbine falls on the drone, not a big deal, right? So you can do something there pretty quick, but to go get a sample, send it to a lab, that takes time and you can lose some of the critical evidence.
Yeah, Joel and I see that in lightning all the time. It rains, so it washes away evidence.
It's like fire investigations too, right? Fire. Like I've talked to some fire experts before, and they're like, the biggest thing is like nobody touches it. It has to be an unmolested, because otherwise the evidence, like if someone goes in there and starts like move, just even like opens a door the wrong way, they can remove evidence that needs to be seen for that investigation to have basically to have efficacy, right? To make sure that they have all the data and everything can be learned from it. Let's go. Let's walk through this step by step. We said we had something come down, whether it's a turbine tower, gearbox failure, blade, whatever it is. Or asset owner calls the OEM. I'm sure at the same time they're probably calling their internal risk group and getting a hold of their insurance or whatever. But what we want to concentrate on here is the OEM process. So they call their OEM. OEM makes sure, in conjunction with the asset owner, site is safe, site is secure. We're good to go. The OEM then starts looking, if they have access to the data, which they usually do, starts looking at data in the background to figure out their things. Then what's the next step?
Then the OEM will send out some of their like experts, like it's some really good people that would go out, especially on blades, and they would know what to look for. They would use the drone photos too to kind of like maybe tell them where to put the blade, what orientation when they bring it down. And they'll go out there, tons of pictures. And then depending on the issue or not, they'll probably take some samples, cut up a couple pieces, put it in a trailer, ship it to a lab. Basically collecting as much evidence as they can, as quickly as they can before, winter rain and everything else kind of washes some of that away.
The on-site investigation that happens from the OEM's perspective is those people are experts in the technology that they're looking at generically, but they're not the people that design the equipment. They're not the people that design the blades or the gearbox, or typically, right? Or maybe they did come out of there.
They may came out of that team, but there are definitely more field-oriented people for these type of issues. But sometimes they will bring out a designer if they need to. Like, it all depends on the case.
This sounds a lot like the airplane business that I've been in for a long time. When there's an accident investigation, the aircraft manufacturer sends out experts. Now, those experts are knowledgeable people about the airplane product, but they're not specific. Like, they didn't design the elevator. they didn't design the propeller, right? But they have a pretty good understanding of what the systems are. So when those people are out on site, photos, images, samples. Now, the sample piece, what's happening with those sample pieces that they may collect? Where are those headed off to?
In GE's case, they had to have one or two labs, so it'll be sent to one of those, and then they'll do microscopy on it. So like cut it down into little pieces, get a high-end microscope. I'm not an expert on this. I was just more of a person who kind of looked at the results. And then as someone who's like leading it from a engineering perspective, they'll spend a lot of time with the person who cut up the sample and whatever conclusions they have for adhesion, for example, or number of layers, stuff like that. So they're getting really detailed about whatever samples they collect. So you need somebody very knowledgeable deciding which samples to take, and then somebody extremely knowledgeable on, how to go look at that sample.
So being in an OEM too, you have, they're the largest people, right? So you've got access to all kinds of different engineers. So if you're sitting there and you go, all right, here's the specialty RCA team. We've got the investigation going. We've got some samples taken. We're at this stage where we're trying to figure out what's really going on. All right, we've got microscopy done. Great. Let's get a hold of, that may be the glue expert, or it may be the fiberglass expert, or the carbon fiber expert. And you have access to all of those, or you would have had access to all of those people, right? So you can send an email to someone down the hallway or walk down there and say like, hey, let's look at this. And that's one of the advantages that the OEM has, is it not only do you have access to data, but you have access to experts within each of those kind of, we're going to say, maybe call them sub-silos, right? Because it's not just like you're a composites person. You're actually that really toned down one in there. And so you would go then to those people to get their insights on what may have happened.
Yeah, and there might be someone in the middle who's more of a like blade expert of everything, right? Just knows all of it. And they might kind of say, oh, let's go talk to this person because they know a little bit more about this, or they designed this part of the blade. And, you go huddle up over there and kind of walk through what's going on.
So does that, in an OEM case, and I know this is a very generalized statement, but does those RCA investigations, when you're dealing with or trying to engage those individuals, do those take precedent? Or is that kind of like, Yeah, we'll get to that when we get to it. We're working on a new blade design.
It's like number 2 under safety.
Wow. Way up the chain.
Okay, so now we're at the stage where we've got data, we've got some samples possibly, we're back in the office and we're engaging the experts. What does that look like?
Yeah, who's at the table there?
Depends on the issue, but yeah, I mean, you're getting the people that probably have like the most knowledge in the subjects, right? The people who've been around the longest, or maybe even designed the blade or designed a similar blade. They're in the room, you're looking at data, trying to understand, hey, is this a one-off or is this something we need to be worried about? Like, that's a very key question. And that's kind of part of like, well, the second or third part, which is like containment. Like, how do you stop the bleeding? Is this a fleet issue or not? That's one of the biggest questions you're trying to answer as quick as possible.
Yeah, that's where you kind of get into that not pseudo gray area of engineering and business, right? Because at some level you have to worry about what could financially be impacting the rest of the larger OEM scale as well.
Yeah, I mean, I felt like Lisa G, like that was kind of isolated from the business part. It was more, hey, technical people, you go figure this out, work with the customer resolution people, and they'll help with the customer information part. But we were let go to go figure out what was going on.
So does some part of that involve looking at all the SCADA data from the turbine? Because I would think some of the issues that are happening on blades in particular may be related to the operational aspects of the turbine. Like there's some tweaking going on.
There was like 2 sets of data. There's like a high-speed data that you can look at the time of the event. And you can actually almost tell which blade did what when, like through a rotation. And then, from there are probably some 10-minute data points that could indicate something if you're looking at it for a fleet issue. And then you can start kind of cutting the deck with 10-minute data if you need to. All depends on the issue.
Yeah, off air we were kind of talking about one thing that was cool being in an OEM is that if you're connected to the controllers, you have the possibility of going like, hey, if this is a, I don't know, GE15 problem, give me all of the data for the GE15s that looks like this. And you had access to that data of possibly saying, give me 5,000 turbines of data so we can start looking at something statistically.
Correct, yes. And I had some very good data people on the team. They're very knowledgeable in turbines too, that could go take a look at 10,000 turbines in 2 hours, come back with an answer.
The rest of the industry just doesn't have that, right? That's the thing we're always talking about, like sharing data. Wish we had more of this, wish we had more of that. But the OEMs are the ones that actually hold the cards there.
Yeah, especially if yes, they do.
But they have also the engineers that designed it, which is the key to this. So you can have all the data in the world all you wanted, but unless you have the knowledge behind what that data means, it's pretty much pointless. It takes a long time. Well, Jonathan can attest to this. It takes a long time to become an expert in a particular aspect of a wind turbine. That's what Rosemary's about on our program. Like she's been around it a long time, and she's very knowledgeable about those things that she knows about. But unless you have those people on your staff that just live and breathe that, I don't know if they make heads or tails of what's going on data-wise. And I think that's why getting the OEM involved is really critical here, right?
Jonathan, I want to ask you one more question about this. It would be more of an internal thing. So at what stage or how are they treated different if you go like, if you get to a split in sitting in the conference room with everybody, all the technical prowess in there, and you say, all right, guys, this looks like a one-off issue or this looks like a serial defect. How do you treat those differently?
Well, first you need to verify that. So like you get to the point where you're like, hey, I think this is a one-off. And how do you know? Like you get chief engineers involved and like a lot of people have to sign off to say, hey, freak event, one-off, whatever it was. If it's something that you're concerned about is more widespread, then that's when you probably bring in more people. You're looking at the data, potentially instrumenting turbines. You're going to go to field inspection, samples. Then that process starts taking a longer time for sure.
I know this is a weird thing to bring up here, but I was just reading the news. This is literally yesterday. I saw in the news SGRE laying off all of the engineers that designed the 4X and 5X. So now in SGRE, if they're going to continue this investigation into what's actually happened here, all of those people are gone.
Yeah, I'm not sure. Did they like lay off leadership or did they lay off design engineers?
It said engineers.
A little too soon, in my opinion. Unless they know what's wrong.
That's my same thought as well.
Well, let's go back. I want to step back to the chief engineer aspect of this because I think maybe GE is a little bit unique in that they still have chief engineers. A lot of the engineering industry has sort of pulled back from that over time. but when I worked for GE years ago, chief engineers were a real key to making the operations work. Within GE, and it doesn't have to be specific to GE, but I'm just curious here. They still have chief engineers that are responsible for a particular product line, right? That really know the ins and outs, and that's a very unique person to be able to do that. But there is a focal point on the engineering side, right?
For like, you mean like a 1.5 SLE, or do you mean like a blade?
A turbine model, right? Is it turbine model? Or is it blade model? Maybe it's by blade.
So I'm not sure now, but there's chief engineers for like the major component areas, but there's also a overall like systems engineering chief, and like the system engineers are more responsible for the whole product.
Okay, so they even have chief engineers lower down into the main components then, that's the way I would do it. Yeah, okay, that's the way I would do it. So is that your really first touch point? Like, hey, chief engineer, this happened. I just heads up, this is coming. Is that sort of your focal point if you're out in the field and doing the RCA work? Is that your key contact, and then the chief engineers grabbing the people to bring into the conference room? Is that how it flows?
No, it was more of the systems team was leading the effort, at least for these major issues, and then they would be reviewing that with the chief engineer. And you definitely bring the person in there so they know what's going on, especially with a big issue. Like, they're going to be involved, but they're not leading the investigation. But they are approving it at the end. They're asking questions, asking to go back and go look at something else, because you want to be right.
You want another set of eyes on whatever the quote unquote answer is, right? And someone who's knowledgeable about the product on a deep level to go, yes, that makes sense to me. Okay, that's a good approach.
In the big issues, there's more than two sets of eyes looking at it for sure.
So you're all at the table. You kind of fleshed out. It's either a sort of a system-wide issue or a one-off. You make that decision, and then from there, what's the support role look like? Like, what are you going back to the operator with? How much information is brought to them? What do they need to know to get to the next step of repairing, replacing, whatever the answer is there?
Like part of that safety review initially about like how to go approach that kind of helps with the how do you get the turbine back up and running, right? Like what you need to do, and there's teams probably separate from the RCA that will like help with the foundation analysis. Can you go put another turbine up on there, like stuff like that. The RCA team's gonna stay focused on, hey, what happened? What's the root cause? How do we correct this and then prevent it?
That's more of the client success people then, right? Like the client interaction, they'll then take load of what happens next. So if they have to deal with the asset owner, their insurance company, their consultants, or something of that sort, that's a different team.
Yes. And I'm happy that was a different team, because that would just slow it down even more.
So that someone there in the customer success reign takes the kind of the control of all of the externals per se, and then navigates that mess.
Multiple times, like I would be presenting to customers on like where we were, like RCA updates throughout the process. So there were definitely touch points and stuff like that. But the hey, how does it get this turbine back up and running? That wasn't really
okay. That's a good way to run it. I've seen just from mostly outside the United States where it does seem to be a linear process, that nothing happens until the turbine to the RCA is done, and then there's a team that then figures out what the next step is. That doesn't make any sense to me. In the United States, what you explained makes sense to me. Hey, let's get the operations up and running again. Let's get that done. We'll figure out the problem on the side. So you got a parallel effort going on instead of a linear effort. That makes complete sense to me. So then in that parallel effort, then is there a lot of crosstalk between the two teams, or is it engineering, RCA? Hey, we had an engineering issue where we really need to hone in on this. The customer side is getting the customer back up and running again, so they're productive. But in the meantime, you're paralleling an engineering approach. Okay.
Yeah, I mean, most of the customers, the bigger ones I dealt with, they also have two teams. One's like, I need to make power. The other one's like, do I need to worry about my other turbines? Like, so there's multiple teams pushing on multiple teams.
These bigger operators too, in the United States, if you're dealing with those, your NextAirs, your EDFs, your RWs, they've got their own engineering teams as well. So more than likely, they're running a parallel process of you guys. Maybe grabbing some data from you if it's available or something like that, but they're using their own data and they're running their own analysis to come to their own conclusions at the same time, because they've got to safeguard themselves, right? That's part of doing business.
Yeah, and there's having that good relationship is also key too, because there were many times where I had to call up one of the really big customers and be like, "Hey, can we go instrument a turbine, or can we go collect some samples? Can we go do this?" And that relationship's really important, but also that speeds up the process, right? Especially if it's not a one-off.
Okay, that makes sense then. Yeah, because if it's engineering collaboration, things tend to go faster because there's an understanding we're all trying to solve a problem. Let engineers alone to solve a problem, they'll pretty much go off and do it relatively quickly. We put a bunch of insurance people or management people on top of that, it tends to slow it down.
Every time.
Well, yeah, I mean, and that's a good point. If you're an operator, that's one of the things to remember is like, look, you're paying these people for a reason. Let them go do their job. Just make sure it's moving, and that's it, right? You're going to get to the fastest answer that way instead of trying to interject a bunch of politics into it.
If you're an operator and you run into one of these issues and you're not sure where to turn, call IWTG Consulting. They've got the expertise, right, Jonathan?
It's a fun thing to do. I mean, you really are an investigator, right? So like you get to go solve a problem. It's one of the funner jobs I've had. I really enjoy doing it.
You're doing puzzles, but at a grand scale.
If you get happy when something breaks at home, I'm that type of person. I'm like, yes, something broke.
So what does the end product look like after all this? Is it just a report? Is it a meeting? Is it a report in a series of meetings? What happens at the end where you say, we know what this is. It's this one-off turbine issue. Here's what happened. Here's how we do to prevent it going forward. What does that closeout look like?
The closeout with the customer, it's going to be a meeting. It's going to be, a presentation of some sort. And sometimes it's a report depending on who they are. And it's going to be like, does everyone agree this is what it was? And 9 times out of 10, by the time you're through everything, everyone kind of agrees.
You hear from the field that there's, you'll hear a lot of complaints that, hey, the OEM and the operator just don't agree. Like, I think politically they may not agree, but engineering wise, they probably do agree, right? Usually in the financial part, they never agree on. Engineering wise, though, it does seem like there's an agreement typically, right?
Not always day one, but usually by, midway through to the end, like mostly both teams have a good idea where it's kind of heading, right? There's going to be some one-offs that it's just like no one knows. Like that will happen, but that'll be really rare. But I don't remember many that says like, I know it's this and someone else says, I know it's that. Like usually there's enough smart people that have looked at enough data that they can convince one or the other that they're more likely right.
Yeah. And that, like you said, Alan, that's on the engineering side, right? What ends up muddying the water there is when you get an insurance company and then they grab a lawyer and then there's arbitration and there's all this and people are sitting there like, who's on the hook for the $4 million and that kind of stuff, right? That's where it gets lost sometimes.
Well, that's good though, but the OEMs are trying to keep the engineers separate from that discussion because at the end of the day, it's all about operating and producing power. If you get tangled up in all the money part of it up front, it'll never come to a solution. And I'm glad that at least GE side that they're working the engineering solution, which makes sense. That GE's an engineering company, and that all makes sense to me. And this is where IWTG comes into the play, right? That if you're an OEM, you have your team. If you're an operator, you don't have everybody you probably need, and especially some of those mid-tier operators, even the large operators, don't have all the experience with a particular turbine type because there's just things you just don't know, right? You don't dig deep into a system architecture as an owner of a turbine. You know how to operate it, but if there's complex things happening, you may not have those details. This is where IWTG comes in. You call Jonathan up and say, hey, how do we go debug this? What's going on? And how do we flow through this to get to the right engineering answer?
Yeah, I think it helps just also like explaining to some of the, I guess, smaller customers of like what the process is, kind of help them, support the OEM with whatever process they're going through. It's been pretty helpful with a couple of customers I've worked with.
Yeah, I would say one of the biggest hurdles there is navigating the whole thing, but it's understanding who to talk to and what data that needs to happen and all these different things. Because that's a big problem in the industry too. Is like people you throw it at a site manager. That site manager is so dang busy with just the everyday stuff they have going on. They just go like, man, hey, I got this. I'll deal with that later. Right. So if an asset owner wants to actually get moving on this thing, having someone that knows what they're doing is a good help.
It's a necessity today. Yeah, there's definitely a place for those experts. And in the United States, there's not a lot of people walking around that have that sort of expertise. You have to spend your time in the trenches. And Jonathan has done that. So this is why it's so good to talk to him, because he's been there and he's lived through it. Jonathan, how do people get a hold of IWTG and how do they get a hold of you directly?
My website's www.iwtgconsulting.com. They can reach out to me there. I'm also on LinkedIn.
And Jonathan, I really appreciate you coming on the program, and we want to have you back because you're a wealth of knowledge, and it's good to get that knowledge out into the industry.
Thanks for having me. I really appreciate it.